So let's take a look at ICF charts, which kind of look like ICE charts, but they are completely different. Since you're used to solving things with charts, this is what's a little bit different that you'll be seeing us doing instead of the factor label method stuff. So we're going to write down a reaction. So we've got NaOH plus HCl, and it's going to go to NaCl plus HOH, which is water. Okay, so now what you used to do in Gen Chem 1, what we taught everyone was to do 2 factor label charts. So we're going to write down some initial information. Let's just say it's 100 milliliters and 1.0 molarity. And then let's just say it's like 50 mils and 1.0 molarity. So here's what you would have done in Gen Chem 1. You would have set up a factor label chart, and you would have gotten an answer, and you would have solved for just one of the 2 things, like NaCl or something. And then you would set a second one up and solve for the second one. You'd say, well, one was too small, one was big, and that's how I know which one is the limiting reactant and which one's making the real amount of product. So now we're going to switch to charts, because now you're starting to get used to solving things with charts. And so what we're going to do is actually put everything in moles and just do some subtracting and do this in a little bit of a faster way. So we do have to have this in moles. So you might be able to see this in your head. I'm going to go ahead and do the 0.1 liters because that's 100 milliliters. And remember, my molarity is 1.0 moles per 1 liter. So that's going to give me 0.1 moles initially of the one thing. Now, some people like to do these in millimoles. And so millimole is just like, milliliter to a liter. So some people would write that, multiplying by 1,000. You'd get 100, well, not 1,000, but you get 100 millimoles, and you just do it in millimoles. The only difference is if you like doing it with decimals or not. So I'm just going to keep it in decimals, but you'll see it both ways. All right, so we're going to take the second one. We're going to convert it moles using the molarity, moles per liter. And so that gives us initially 0.05 moles. And those are our 2 initial amounts. I'm just going to rewrite these at the top just so it's like more clear of the reaction that we're doing here. And we're going to make the Na and the Cl and the H2O. So we don't know how many of those that we've made yet. Okay, so I've got 2 initial amounts. You can see I've got them highlighted right here. All right, so I've got 2 initial amounts. And what I'm going to do is I'm going to subtract the smaller one of the 2. So you can see the smaller one is the 0.05. I'm subtracting that from both sides, and then I'm adding it to both sides. And the water doesn't matter. And so this is why this is different. This is actually doing a reaction. So we're removing some of the NaOH because it's being reacted with the HCl. 0.950, and then that one goes to 0. All of it's used up, all the HCl. That's the limiting, by the way. And then that we've got left over the 0.050 moles of NaCl. So that's how much NaCl would be made in this reaction with the HCl as a limiting reactant. So for all of these, if I were to do something with this with the R chart, I would have to add the ice chart. I would have to add a volume in here. So you'll see I'm adding the 100 plus the 50. I'm putting it in liters, so it's 0.150 liters. So if I'm going to put this in an ice chart or do something else with it, I've got to divide both of these mole amounts by a volume.